Hi guys, welcome to Learn Electronics Repair. This arrived in the post a couple of days ago. So this is a multimeter from FNIRSI. First time I've seen a multimeter from this particular brand. They sent me this free of charge, but I've been asked to give an honest review of this. I'm not being paid to make a review. I'm not being restricted in any way on what I think of this piece of equipment, so I will, to my best ability, give an honest review of this. One of the things I noticed straight away about this multimeter is it has some features which you don't always find or generally find that may well be useful. So let's have a quick look at A, how much this costs. Let's start with that straight away. And B, the extra features this seems to have, and then we'll give it a test and let's see how well this works, both for repair work, which is a sort of thing obviously that I do, and for general hobbyist use, electronics use. Let's see if this is a good choice. Here is the multimeter. This is on FNIRSI official store on AliExpress. And the first thing that stands out is these three measurement modes, it says. So it says it has a general mode, so this is your normal use of a multimeter. It has a recording mode. Okay, this looks quite interesting. So in the recording mode, it says a real-time measurement curve, recording the minimum and maximum values during the measurements. That could be interesting if it works well, because sometimes voltage is changing too fast for you to really see it. You may have to go to your oscilloscope if you have one, so we have a play with that. And the last option is this monitor mode. I have seen this on another handheld scope meter. I tried a different make. So this effectively, you can tell it to give you an alarm when a measured value is greater or less than a set threshold. So if you think some fault conditions occurring where the voltage is going up or down, you can get this to give you an alert when that happens. So that's what we have here. Price, we can see €45.83. This is on special offer at the moment. Note here, price includes VAT. Depending on where you live, you may or may not pay VAT. Here we don't, so I would get this for 21% less than that, which is just under €38, and that's with free shipping. So that gives you an idea of how much one of these would cost depending on where you live. Okay, so let's get straight on. Let's have a look at this multimeter and let's see what I think of it. First thing first then, let's open this up. And what do we have here? Well, we have less reflection on the camera, so that's a good start. Little FNIRSI badge things. You always get one of these, it seems. One user manual. Let's see, is this multiple languages? Yes, definitely multi-language user manual. I have English here. Okay, so we have a fairly good user manual here. So 10,000 count. I've noticed on the advertising it says 9,999 counts. Maybe one count doesn't matter that much between people. So we have all the usual volts, ohms, capacitance, diode, bleeper, release hold, auto mode, manual mode. Okay, non-contact live testing, milliamps, amps. I do like a multimeter to have a microamp range, which I'm not sure this has, but I must mention that I do like that. It's useful in some electronics repair. The same with volts. I'd like to have microvolts or millivolts at least, and we'll see. A little bit of information in normal mode. Well, that's how we use a multimeter, so hopefully this will just be intuitive. Yeah, this does a thing where it automatically switches between volts, resistance or continuity. I've seen other multimeters that do that. Resistance, diode. Okay, So you know what, guys? I think we'll just get on and try this. Frequency as well, temperature measurement as well. I assume you need to get a thermocouple for that, but that is just an assumption. We do have a milliamps range. Oh, okay, good. And then we have this recording mode. Real-time measurement curves. Records minimum maximum values, okay? And saves the data on top of the regular mode. We'll have a good play with that, that's for sure. And the monitoring mode last, which we just discussed. Okay, so that's what we have. Let's just check the ranges quickly. So voltage down to, well, that's the lowest range, so about a millivolt is the lowest this can read. AC the same. Yeah, this goes into microamps. That's nice. I'm quite happy with that. AC current also in microamps. That's rather nice. Frequency up to 10 megahertz. That's quite standard for a multimeter, actually. Same with the resistance ranges. So down to 0.1 of an ohm. That's the same as my fluke. No, actually, my fluke will go to 0.01. Okay. And that's it. Right, let's have a look at this. Okay, it's a bit of weight in that, actually, more so than I really expected, but this has the battery in, which is supposedly quite a high power battery, so this should run for a long time. I do like this on multimeters these days, that they are basically rechargeable, USB-C, something that should have been done years ago, to be quite honest. Okay. I think we can find a way around this quite easily. Let's see. Charging lead. And some meter probes. Let's have a quick look at these. Oh, nice sharp ones. This is what I like to see. So it comes with nice sharp probes. I do like that straight away. Seem to be fairly standard quality for these things, similar to the ones that I buy individually. Yeah, okay. 1000 volt max it says, which I believe is also the maximum rating for this meter. Okay, let's switch her on and see if she's charged. Okay, asking for the menu. So let's see, is this thing really intuitive? Yeah, so across. Okay. Auto mode. We'll have a quick play with this. This is not a mode I generally use particularly. I think it makes the meter take a bit longer to read the value, but this is common for all these meters with the auto mode on. Let's have a look. So again, I haven't read the manual quick glance, but auto mode should give me continuity. Yeah. We'll try a low value resistor in auto mode. So this is a 1 ohm resistor. What does it tell me? 0.5 ohms. This actually is a 1 ohm resistor. Okay. I will double check that. Yeah, that is a 1 ohm 1% resistor. I'll try another one. But we'll also try this in the manual ohms range as well. It'll probably behave differently. 0.6, okay. First one again. 0.5. Interesting, it sees the difference between them. Try a third one. 0.5. Okay, so we can see what it's doing with low value resistors. Let's try with high value. Or even with something in between. So this is a 10k resistor, 1%. Yeah, it reads it. And lastly, this is a 10 meg resistor, 1%. So this is the highest value I'm likely to come across, really. It doesn't read it particularly accurately, but it does read it. I'll just check this is a 1% resistor. I think it is. Yeah, that's a 1% with the brown stripe. Again, I'll reserve my judgment slightly on the accuracy because I'm going to try it in the normal mode. But let's just check this auto mode on volts as well. So I've switched my bench power supply on. I'm on 5 volts. What does this read on auto mode? Auto mode, yeah. But click and it goes to voltage range, so we can read that. Let's try a low voltage. I have my power supply set to 0.1 of a volt. What does it think of that? Oh, it thinks it's a resistance, but this happens with these auto kind of multimeters. You need to get to about a volt. Yeah, just turning the voltage up. Yeah, once you go above a 0.5 of a volt, it reads it. Okay. So this is a sort of a limitation you find with these auto ranging. Okay, let's try some proper ranges. Okay. So we want to go into volts range. So I'm guessing we press this one. Volts DC. What's it think now? Well, you can see I have my power supply on 1.7 volts. It's reading 1.8. Let's turn this down. Yeah, and now it will read low voltages as you would expect. Okay. Point 0.1. I'll just compare that with my Fluke, just out of interest. Okay. 0.1 of a volt. I will say this Fluke meter is not calibrated, by the way. It's not been calibrated for a long time. But let's see what it reads. Yeah, exactly the same, 103. So they compare the same. Let's go up to a high voltage when the maximum of my power supply is 32. Again, might as well use the Fluke since I have it in my hand. 32.14, the FNIRSI. 32.18. Close. Okay. Next range we will try, well, what does it give me? Volts AC. I don't easily have an AC voltage source here apart from mains, so we will try that. Okay. 229, 231, yeah. So on a quick test, AC is fine, but I don't really have anything else to hand particularly to measure. Oh, maybe my signal generator, but we'll use that for frequency testing in a bit. Okay, so yeah, that seems to work fair enough. Let's go. So ohms range. So I'm now in the manual ohms range. It's auto ranging, but I've selected ohms rather than using this auto feature. And in my experience, this works better. That's on other meters I've looked at. So these are the 1 ohm resistors. It's reading 1.1. So you see it reads more accurately now when you're not in that auto range. This is why personally I don't use auto range. 1.1. That one reads 1.3. One was reading a bit different from the others before. Let's look at the Fluke. So as I mentioned, this is not calibrated. I've had this since the mid-90s, but on the low ohms range on here I do actually have a calibration built in. So if I short the leads together and hit the button, you'll see it's calibrating. Okay, giving me 0. Let's check these resistors on this one. 1.1. 1.1 again. Yeah, they all read the same on this one. I'll go to normal ohms range on here as well. You'll notice that this meter doesn't zero properly on normal ohms range. And I suspect this one actually does. Yes. So, as you'd expect, it's going to read 1.4, 1.5. That may well be the fact I say this isn't calibrated. But it's a good indication, and we can see that the 2 meters are pretty much reading the same sort of reading, same ballpark. Okay, let's take a 10k resistor. What's this reading? 10.06. Okay, what does the fluke think of that one? .07. You could say this one's closer. On the 10 meg resistor, let's have a look what these think of these high value resistors. So again, the FNIRSI, let's have a look. Got a good connection on this one. 11.2, so that's reading that quite a lot higher. Again, go on to the fluke. Well, actually, it reads it the same. I'll try another 10 meg resistor. Let's see how that reads, because these should be 1% resistors. Or so the theory goes, okay? Or so the markings go. That's a better way to put it. What's this one read? 10.2. So 10.2. I have to question whether these are 1% resistors, even though they are clearly marked as 1% resistors. Make your own mind up about that one, guys, but I'd say the 2 meters read the same. Okay, what's the next option we have? Oh, capacitance. Okay, well, we have capacitance on both of these meters, so we can give it a go. Yeah, capacitance. Well, according to the manual, this should display down to 1 picofarad. I don't know what the range is on the fluke. Let's see if this will actually do it or not. No, it doesn't read that low, but there again, I doubt this one does either, to be honest. As I expected. In fact, this one actually only goes down to 10 picofarads at the least. Okay, so let's try the capacitance range on something a bit more common, like 100 nanofarads. What does it say? Yeah, 95.6. I do rather like this scale at the side of this. I'm not sure how really useful that is, but I like it, yeah. So 96, let's have a look on the fluke. What's this think of the 100 nanofarad? 95, a bit less, so again you could say this is a bit more accurate. And we'll try a higher value one. So this is a 3300. Now, in my experience, multimeters with capacitance range, all of them, take a long time to read capacitors. That's why I have a dedicated capacitance meter. It does this instantly, but let's have a look. You see, nothing happens. And then it does, 2,964. I'll just short the leads together to make sure there's no charge in that. And we'll go again. So, black to the negative. Let's do it again. So what do we have? Yeah, you see, same thing. I'm not sure how high the fluke reads. I don't normally use this at all as a capacitance meter, but let's have a look, see what it thinks. Okay. Yeah. Reads it very similar, but you see how long this takes. Just as an aside, by the way, this is why I have a capacitance meter. Yeah. Apart from the fact this reads down to picofarads, the other reason is quite simply, we take the same electrolytic capacitor, I'll short the leads together. Okay. Yeah, see 3.02. But that is the same, you've just seen on the fluke, that is the same, yes, one of those little bugbears that I have. Now this is where the fun will start. I normally check this first, but we'll go to diode mode. So this has a diode mode. Does it also have a continuity? No, it has just literally a diode mode. Okay, so we go to diode mode. Let's see what it does. So, silicon diode. It measures it, but it doesn't bleep. Okay. Schottky diode. They should read about 0.15 or 0.2, something like that. 0.172. It reads it, but it doesn't bleep. Short. It bleeps. Yeah. This is basically how any multimeter works, really, apart from a very few. The very few actually work quite differently to that. And FNIRSI, you're watching this, really be very interesting you guys implementing this, because so many repair guys like this. So much we even built our own Mr. Bleep adapter. We've got one built into a multimeter, in fact. And this one on the fluke reads 0.5 like that, normal diode. But listen, it bleeps once. Schottky diode bleeps once. Our Mr. Bleep gives a different frequency, by the way, on the Schottky. And then short the leads, continuous bleep. This is what multimeters should do, okay? But I will say there's very few that will actually do that. Not only expensive meters like the Fluke, I don't know if the later models all do it or not. There are some in this price range that will, but they're very few and far between. Something I don't really understand, but there we are. I expected it to do that because that's what they basically all do. Let's just try a few more ranges and then we'll try this recording facility and the comparison facility. So, no contact voltage. Oh, I'm on temperature. It didn't come with a thermocouple, so I'm guessing you need a thermocouple, so I'm not going to actually test that. Okay, this will be the NCV, non-contact voltage. Let's try it. Oh, it's sort of like a proximity meter. Yep, that definitely works well. Hertz range I noticed, so let's have a look at this. I have my signal generator set to 10 kilohertz at the moment. Let's see what the meter says. It says 10 kilohertz, okay. And then we can just change the frequency a little bit. 11, 12, 13, 14, 15. Let's go up a few ranges on this. 115. Let's go above 1 meg, okay. This frequency generator goes up to 10 meg. That's the max, and that actually says 10 meg, 9, 10. Okay, so this is giving a very accurate reading of the frequency. Yeah, that is really close. I mean, that's on 3 meg, and that's on 3.001. I don't know which ones are slightly off. It could well be the generator. This was quite a cheap thing. Yeah, I'm down at 50 hertz now, reading that quite nicely. And it's also reading the voltage quite nicely on AC. Just turn the output up, yeah, 2.7 volts. Down to about 0.1 of a volt, so yeah. Now we can see AC voltage works just fine as well, at least at 50 hertz, which is probably what it's set to read anyway. But it does also read AC at higher frequencies as well. Okay. I can't tell you how accurate that reading is because I have nothing to compare it with, but yeah, certainly AC voltage is working fine. Okay, milliamps and then amps, and then we look at the recording facility of this. So this is something I regularly want to test when I'm repairing, which is the current drawn from the CMOS battery. Normally this should be somewhere in the region of about 1.52 microamps up to about 10. If it's more than 10, chances are you've got a faulty chipset. So to do this, we put the meter into milliamps range. You can see onto the top of the CMOS battery. Then we push the little thing back, the little clip, and that's telling me it is drawing about 1-2 microamps, which is within the range you would expect. So this can certainly read low current like that, which is something the fluke meter can't do, by the way. This has 40 milliamps as the lowest range. I normally use my Aneng meter for this, but this certainly does it very well. So yeah, give it good marks for that. And now we have my power supply. I've put the current limit on at the moment, so it's probably limited to practically 0. Let's try this. Yeah, 0 amps, that's what I expected. Now let's just turn the current up a little bit. Yeah, so 30 milliamps, 150. You can see it's reading accurately, at least as accurate as this is telling me. Actually a decimal point better than that. Let's just go up to the 10 amps and see. Well, in actual fact, the current won't go above 5 amps. Just realised it's actually a 5 amp supply, this one. I do have a 10 amp one, but we use it on the other channel, the electronics channel. So at least I can test this. That's 5 amps going into it quite happily. So amps range, yeah, I'll give that a good working. So now there is this recording and the alarm feature. So let's try these. To get to the recording mode, we just hold the menu button in for a couple of seconds. We get to this menu, and you can see we have options: monitor, recording, regular. You have to press the right arrow to select this menu. Recording. So we're now in recording. I'll hold the button in for a couple of seconds, and this is the recording mode. So I'll attach my power supply. At the moment, by the way, it's just open circuit and it's picking up random noise, if you like. Interesting. Let's connect to my meter. Okay, so yeah, we've gone to a steady voltage, 14.7, which is basically what you see on the power supply. Let's change this. Yeah, so it's effectively recording what I'm doing on here. Kind of like a slow oscilloscope, I guess. That's interesting. I wonder how fast this thing can react. I'm just making it very fast as I can touch on here. Seems to be some limit to how fast it can do it. I'll tell you how we're going to test this. We're going to test this on the BIOS chip to see whether it can actually see the chips being accessed or not on the motherboard. That'd be interesting. I don't think it'll react that fast, but hey, I don't know. Yeah. So let's try it. I can see it changes the range once the trace goes off the screen. Okay. Okay, so that's the recording mode. I had to look this one up. So this is one case where this isn't intuitive, by the way, is the monitor mode. So I'll just show you this. If you go into mode selection, and you set threshold. So you can set here threshold voltages, example plus 15 and plus 22. Now, you can't put the maximum more than the minimum, which seems kind of like back to front to me. So if I go to maximum here, and I increase this, okay, you'll see I can go down below the minimum, yeah. And hitting the down arrow, I can go up to 23. Ah, now I have got above it. No, I haven't. I haven't got above it. Look guys, I've put it onto minus here. Let me show you again. So go to here, change this to plus. So I'm now on plus 21. So the minimum is plus 22 and the maximum is plus 21. And you'll see that I can't actually go more. I can go less, but I can't go more. And to me, that's kind of like back to front. What this actually then does, if you come back to the left out of this menu, and we go to mode selection. Okay. And we then choose regular, not monitor. If you choose monitor, okay, hold the button down, this will come back into auto mode or volts mode. And you'll see that if I change the voltage on the power supply, so I'm around that range I set, nothing actually happens. Yeah, it's just reading the voltage. If we go back into the menu, hold the button in, okay. We go to regular once you've set the monitor on, okay. And now we're in the monitoring situation. Can you see it's saying minimum? So it's making a bleeping noise. And that is telling me that the voltage is below what I set as the minimum. If I turn my voltage up, I'm now in range. I'm now above. Okay, so that's how that mode actually works. Personally, I don't think that's explained well in the manual at all, so I have shown you. So make of that one as you wish. What we are going to try now is that slow oscilloscope type mode to see whether this can tell us if the motherboard is accessing a BIOS. That would be interesting. So here's our motherboard. This one has the BIOS from here, main and backup. Pin 1 is the select pin. So this would switch normally between the high 3.3 volts and 0 when we boot it. And if we see it doing that, we know the motherboard is accessing the BIOS. The question is, can this meter tell us? Yes, look at that. So we can clearly see, although the trace didn't go all the way down to 0, it's now time to 0 because I've switched it off. But we saw activity on there. Let's go again. Switch on. Look there. There. That's the first time I've ever seen a multimeter that can test if a motherboard, or a graphics card for that matter, is accessing the BIOS. Interested to see if it accesses the backup one. I've never tried this before, but let's have a look. No, it doesn't. You wouldn't expect it to, because you expect it to be reading the main one. Okay, switched off again. So we know that was not a fluke. Yeah. One more time, because I want to see this again. Switch on. There. It's reading the BIOS. Wow, that's impressed me. So all in all, I have to give this a good review. I mean, I started this review, I'll be honest, another multimeter. Anything special about this? But that, to me, that last feature, when I see it doing that, that is special. Not sure about that threshold thing. I think it's a little bit strange how it's set in the menus. Okay, I know how to do it now. Otherwise, as a multimeter, I think this works just as well as any other general multimeter. Yeah, sure, you can get high precision instruments at high precision money, but it was working pretty much as well as my fluke, apart from, of course, the thing with the diode mode and continuity. But there's so few multimeters that actually work that way, although you'd expect them to be a lot of them. Yeah, they should all do. But all in all, this works. Milliamps went down to the microamps, so I could actually measure things like current draw from a CMOS battery. Very important thing to measure when you're working on motherboards to start with. So yeah, I've got to give this a good review. I won't give it a score. I don't think 10 or 12 out of 10 or 8 or whatever. I don't think that really matters. What matters is we've seen what it can do. I like it. So what do you guys think? Comments below, yeah. But I think FNIRSI have come up with something a little bit different there. Maybe something a little bit special. Okay, thanks for watching. I hope you enjoyed that review, and I'll see you all soon on another Word Electronics Repair video. Ciao for now, guys.